Am I audible to you?
Yes, sir.
Okay. So good morning to all of you.
Good morning, sir.
Good morning. Tell me the EMF equation of DC generator. Tell me the EMF equation of DC generator. What is EG is equal to what? EG is equal to, tell me,
PN pi Z by A.
Pn phi Z by
68.
60A. Though we write here capital N, so in denominator there should be 60. If we write it by small n, then we can also write P small n pi j by A. Suppose we have a design a machine, then can you tell me what is the number of pole? It is fixed or variable? Suppose a machine has
Fixed.
been designed, already designed it. After that, we take it for testing. Can you tell me at that time number of pole constant or variable? Tell me.
Constant.
Constant. So total number of conductor it also be constant, and total number of parallel path it also be constant. Though the machine are designed, so this theta PZA should be constant. So we can write at that time EG proportional to first. First write with constant, then we write with proportional. Constant in into 5. Can I write that? Where the value of constant is P Z by 60A. I can write like that. The EG is equal to constant into n into 5. After that, we can write it EG is proportional to n into 5, and tell me what about phi, and phi is proportional to field current. We know that. You know that.
Yes, sir.
Okay. Then what we write now? Eg proportional to n and phi, and we also know that phi proportional to if. If the speed of the armature is constant, what we write? Eg proportional to phi when or you can also write that n into if, and if n is constant, we can write Eg proportional to if. We can write that. Previously, we know that Eg proportional to n into phi, because P, Z, and A are constant, and 60 is also constant. So we can write Eg proportional to n into phi. And we also know that the flux produced in a coil is proportional to the current flowing through that coil. Here we denoted by it if, because the current is called field current. So we can write Eg proportional to n into if, and if we somehow make the speed constant, then we can write Eg proportional to if. And plot if we plot Eg versus if, if we plot Eg versus if, what is the name of that characteristics? What is the name of that characteristics?
Magnetization, OCC,
Magnetization characteristics, or
OCC,
open
OCC.
circuit characteristics. That means, tell me, what is the condition to perform OCC test? What is the condition? The condition should be this one. We have to make speed constant. If we make speed constant, then at that condition we can plot Eg versus If curve. So if we perform the OCC test, so we have to make the speed constant. So what is the condition to perform OCC test? Tell me.
Speed should be constant.
Speed should be constant. Whenever we have to perform the OCC test, it always remember that we have to make the speed constant. And after speed constant, we if we plot uh, Eg with respect to If, or varying the field current, then we get a curve like that. And previously I draw the voltage building curve of self-excited DC generator, and the curve is like that. This is called field resistance curve. This is called field resistance curve, RF. And the motor, or sorry, generator is like, what we will do on that circuit, we make the circuit first. Suppose if we increase now the value of RFEX, that means external field resistance, the curve should be go higher. Suppose this is second case. This is RF2. If we increase the value of field path resistance, then we get the field resistance curve like F21. After that, we increase to another value. Suppose we go or increase the field resistance path, then it becomes RF3 and curve is like that. Have you understand why the slope is increasing? If we increase the value of REF external, then the value of field resistance in field path is increasing. How do it happen? Do you know? Ayush?
सर वो वेरिएबल रेजिस्टेंस को बढ़ाएंगे.
हाँ, वेरिएबल रेजिस्टेंस को बढ़ाएंगे. बढ़ाने से ये जो देखिए पहले क्या था, RF था, फिर RF2 हुआ, फिर RF3 हुआ. ये कैसे हो रहा है, ये आपको मालूम है?
हाँ सर, स्लोप बढ़ रहा है क्योंकि रेजिस्टेंस बढ़ रहा है, क्योंकि वी वाई होता
गुड. V बाई,
है, आई
ये
होता
देखिए,
है.
यहाँ क्या प्लॉट करते हैं, V, यहाँ पर I, और ये क्या होता है, ये रेजिस्टेंस होता है, क्योंकि रेजिस्टेंस इज इक्वल टू वोल्टेज बाय करंट. दैट मीन्स how much voltage it has and how much current going through that resistance. If we increase to another one, suppose this is R1, and if we draw on same current, we know that we require much or higher voltage. In case of R1, suppose this value is V1, so we can say that if we increase the value of resistance, then it goes in anti-clockwise direction. That means in this curve we say that the value of RF3 is greater than RF2 greater than RF. Can we say that? Ayush, can I say that?
यस सर.
Okay. Then now what is our topic actually and why we read all these things? our topic is critical resistance. Our topic is critical resistance. So write down the topic name, critical resistance. What is called critical resistance? Here we say that the value A3 is called critical resistance. Why? Can you tell me why it is called critical resistance? Can you tell me why it is called critical resistance? Acha, first tell me what is the operating voltage in case of that. Tell me what is the operating voltage in RF curve and OCC curve?
D naught, sir.
This one,
D
suppose
naught, sir.
this is P and the terminal voltage at that time is that much. Have you understand that? Because previously we said that the crossing point of RF curve and OCC curve is the terminal voltage. So in this case, the P point, at the P point, the voltage which is suppose that much is the terminal voltage. In case of RF2, how much voltage? That one. And in case of RF3, you can say that one. So is there any voltage build up in case of RF3? Ayush, can you tell me? In case
No,
of
sir.
RF3, is there any voltage build up from the residual magnetism voltage? And the you can say there is small voltage build up. But with respect to terminal voltage, this voltage build up is neglected. So you can say the field, actually the resistance in field path due to which there is no voltage build up in armature, that resistance is called critical resistance. RC is critical resistance. Write down, please write down what is called critical resistance. The resistance in field path, the resistance in field path due to which there is no voltage build up in armature is called critical resistance.
So once again,
The, the resistance in field path due to which there is no voltage build up in armature is called critical resistance. Can anyone tell me what is called critical resistance? Khushbu, can you tell me what is called critical resistance?
Yes, sir. Yes, sir.
Just tell me what is called critical
The
resistance.
resistance in field part, the resistance in field part due to which there is no voltage on armature is called critical resistance.
Yes, sir. The field path PATH.
Okay, sir.
Okay. Then the next write down the heading critical speed. Then our next topic is critical speed. Previously, what we said that EG is proportional to n into 5. If we decrease the value of speed, what will happen? Tell me. If we decrease the value of speed, what will happen in the induced voltage? What will happen?
It will also increase.
We are decreasing the speed. If we decrease the speed of the armature, what will happen?
तो डिक्रीज होगा सर जी.
Also decrease the EMF voltage or the voltage which will generate. So suppose we have plot 3 OCC in 3 different speed. Suppose this is N1, this is N2 and this is N3. In 3 different speed, we plot the EG with respect to field current. And suppose this is field resistance curve. Suppose this is field resistance curve. Just please save it or take a screenshot because I have to end the class here due to the power cut. and all the battery of laptop is drained. So